The column analytic solution is a self-maintaining prescriptive tool that allows plant operators and engineers to monitor their columns using historical and real-time plant data. Column analytic estimates and/or predict the distance the distance to flooding or weeping, the type of flooding that is occurring or about to occur, product quality, which instruments are inaccurate in mass balance closure. It allows operators to configure alerts to monitor the planned approach to flooding events and or an off-spec situation. This tool can keep distillation columns operating closer to their operational limit and can help quickly eliminate flooding. In this video, we will demonstrate how to set up an analytic case map, individual measurement or tags, calibrate our models, and calculate and monitor alerts we want to be alerted of incipient flooding events in our column of interest. We begin by creating a new column, Analytic Application. We will monitor a perch tower in our plant of interest, so name the case perch tower. Next, select and import the Aspen Plus simulation for our plant. And a graphic of our plant is displayed. This plant processes a hydrocarbon containing feed which passes through a deisobutanizer tower and then a perch tower. Our unit operation of interest in this perch tower, the feed's heaviest component, isopentene, is stripped off. Select this column and choose Import Column Data. The next step is to map the variables, which are text IP21. The corresponding input variable of the column model input variable or manipulated variable are a key subset to the most basic plant measurement that are required to run the Aspen Plus model. Choose Browse for Graphics so we can select our process graphic and use it to map our tags. We can then hover over our tags of interest, in this case column pressure, then drag and drop it to the corresponding label on the column graphic. Continue to use this method to map the rest of our tags. Then we will map the output variable. For the model output variable are ones that Aspen Plus model predicts, so they're not input. The the model will predict the tags value during runtime. We are required to map the output value for temperature and bottoms flow rate. These are used to determine the column operation. Calibrate the model. It is also important to map the impurities in the bottoms and distillate. We will map the impurities in the bottom and the distillate. We will map these manually. Mapping the impurities will allow us to give correct guidance in a flooding event. For example, it will indicate whether we can reduce the reflux while still meeting the impurities specification. In this step, we can map the control variable. Specifying the control variable will help ensure that the online model will match the effects of the column control scheme. This step is optional, so we can go ahead and click Build Analytic. Once the model has been built, we can calibrate our model. Starting our feed estimation is an essential during calibration because the feed composition is one of the most essential input variables to the column model but is likely to be measured on a regular frequency. Feed composition predictions are computed through a combination of first principle model and data-driven algorithm. It is generally good to have a wide range of for the calibration because the model will only be valid within this range. Next, we can move on to flow reconciliation. This step is necessary for the calibration of flow measurements on the column, which helps determine systematic error in the flow. The flow instrument offset that are present on the instrument within the plan, ensuring that these values are properly calibrated. In our example, we are adding considerably more error in the bottom flow rate because this is a small fraction of the feed. Now proceed to temperature reconciliation. This step is utilized to tune internal column model parameters such as column efficiency so that column models matches measurements observed in the plan. Correct values for these internal column parameters are essential for providing accurate column predictions. Increase the allowable error a little so our calibration produces results within the allowable range. If we look at the stable diagram, advanced tuning, we have the option to enter data here on a flooding event. Aspen Acid Analytics can measure how close a column is to flooding by combining first principle models. When the calibration has exceeded, we can view it results. On the stability diagram page, the key result is how close we are to flooding at the various states that we calculated in the one time in week time period at the top of the screen. The critical tray is the tray that is more likely to flood first. Tray 2 is the critical tray for most steady states, and tray 20 only is a critical tray for a few. We can see Finally, we can look at the feed estimated results, and we can see that we have a number of feed compositions calculated within the specified ranges. We are almost ready to deploy our analytical application. Once it's deployed, alerts will tell us when our purge column is close to flooding first. Though we can preview how those alerts will behave, click Limit to Specification to move on to this step. Some alerts will depend on limit the acceptable column pressure drop for normal operation or an allowed product impurity. The limits we can modify are shown in the table and also in the trend. Our alerts will depend on the limits of our distillate and bottom impurities, graph here in red and green. Click Calculate Alerts. Click Calculate Alerts. After this finishes, After this finishes, continue on to the alert tuning page. The train shows all the text that are used by the alert rule. We can use this train to locate an earlier time when a flooding occurred for this column. In this case, the system shows no alert over our time. An alert was closest to appearing to indicate that we would have expected to see an alert at this time. Click on the green circle. Click on green circle and it changes to a red bell symbol. Then click, then click, then click calculate alerts again. Now that we have tuned this alert to more closely match past events for this column. And tell us that an incipient flood has been detected. It also indicates that we need to reduce the reflux since we are safely within the purity specification. Reducing the reflux would be problematic. In this video, we demonstrated how to create a column analytic application, how to calibrate it, how to calculate and tune alerts, and how to deploy our analytical application and monitor our column behavior online.